Today we're talking about the chain rule for derivatives. Let's consider this function, y is equal to 7x squared. Let's find the derivative. Easy peasy. That derivative would be 14x. Not a problem, little power rule. What if, though, we had this function? How would we find dy dx? It's very similar, except instead of being x squared, it's 3x plus 1 squared. Well, this wouldn't be too bad. We could just FOIL this out, right? Multiply, distribute this out. We would get a 9x squared plus 6x plus 1. And then we could distribute that 7 through. Not too hard to do. And then we could find the derivative. And that would be 126x plus 42. Not too bad. What if this wasn't a 2, though? What if it was something larger? That would take a lot of multiplying. Or we could, I guess, if we wanted to, go out and get Pascal's triangle and go all the way down to the 9th row, the row with the 9 in it, right? That would give us our coefficients, and then we would have all of these powers, 3x to the 9th, and 3x to the 8th, and then 3x to the etc., etc., etc. It would be quite a nightmare to do it like that, but possible, yeah? All right. Fortunately, we don't have to do that. We can use what's called the chain rule. Here's how the chain rule works. We are taking the derivative of, essentially we are taking the derivative of a composition, f of g of x. A composition of functions. We can call, like here is the g of x in here. The outer function is 7x to the 9th. The inner function is the g of x. So that's what we're essentially doing here. And to apply the chain rule, you take the outer first. It's kind of like eating a blow pop. You have to eat the outside before you get to the inside. So start on the outside and take its derivative. Leave the inside alone. When you're eating a blow pop, the gum is in there. As you're eating the outside, the bubble gum is inside, right? So you leave the inside alone. Then you get to the inside. So after you take the derivative of the outside, leaving the inside alone, then we're going to multiply by, not add. Common mistake, kids want to make that a plus. Not a plus. Multiply by the derivative of the inside. Think of it as you're getting into that little bubble gum inside that blow pop. Okay? So this is the chain rule. Another way to think of it, to find dy dx, we can take the derivative of y with respect to a different function. Let's call it u. And then multiply by du dx. In this case, the u is the 3x plus 1. So first we're taking the derivative with respect to u, and then we're multiplying by du dx. Okay, Leibniz's notation, look what Leibniz's notation does. When we multiply, these du's look like they're canceling, and it looks like we're getting dy dx. Leibniz's notation is very convenient for things like that. Okay, either way we think of it, we need to kind of know both, but either way we think of it, this is the chain rule. Let's look at an example. Let's say we have this trinomial cubed. We want to find the derivative. So I get on the outside. We go to the outside. The outside is what's being raised to your power. So the power is the 3. So we bring the 3 down. Bring the 3 down. How would you take the derivative of x cubed? You would bring the 3 down, and then you would write x to the second, right? So leave your middle alone. Leave your middle alone and decrease the power by 1. So right now we have done this first step. we've done the f prime, leaving the g of x alone. And now we're going to multiply by the derivative of the inside, the derivative of the g. So 4x cubed minus 6x plus 9, and we're done. Find the instantaneous rate of change of this function with respect to x in terms of x. That just means we will have x's in our answer, and only x's in our answer, no other variables. Okay. Instantaneous rate of change is IRAC. That's our derivative. Okay. All right. 4 times the 9. We go to do the outside first. 4 times the 9 is 36. Keep your parentheses the same. 2x to the 7 plus 5. Reduce your power by 1. We're just using the power rule there. Reduce your power by 1. And then multiply by the derivative of the inside. 14x to the 6th. Number 3. What is the slope of the tangent line to the curve g of x in terms of x? G prime of x is 33 times 3. Keep your parentheses the same, reduce your power by 1, and then multiply by the derivative of the inside. And you're done. Okay. Let's find h prime of 2 if this is h of x. I am not sure why I put a 2 there. I probably meant that to be some kind of a pi thing, but whatever. We'll do whatever they tell us to do here. Okay, first we're going to find h prime. So this time I start on the outside, but there's no power, right? On these first 3 problems, there was always a power. If there's ever a power, I always do that first. Take care of your power first. Okay? But in this one, there's no power. So what is outside? What's outside is the sine. So I take its derivative. The derivative of sine is cosine. Keep your parentheses the same, always. And then multiply by the derivative of the inside. Now I could write that 4 outside, but it looks funny being outside of the cosine, so I'm going to move that 4 to the front and make it 4 cosine of 4x. And now they told me to put 2 in, so I will just put 2 in. And that's it. 8 radians. 8 radians. What quadrant would 8 radians be in? Okay. What is the slope of the tangent line to this curve at the point when x is pi over 12? Okay. Do you see a power? Because I don't see a power. If there is a power, we must take care of that power first. Okay? But there is no power. So I just go to whatever is outside now. Well, what's outside is a 3, but that's not going, I'm just going to be multiplying by 3. So I'll just multiply the whole thing by 3. The derivative of cosine is negative sine. Keep your parentheses. When you take that first derivative, you keep your parentheses. And now we're going to multiply by the derivative of the inside. I'm multiplying by 2, right? So this would be a negative 6 sine of 2x. I don't mind if you show notation like this, you guys, but just make it very, very clear and obvious that that number is not part of your argument on your sign. Okay? Now we're going to put pi over 12 in for x, and we have negative 6 sine of 2 times pi over 12. 2 times pi over 12 is pi over 6, and sine of pi over 6 is 1/2. So this derivative is negative 3. This looks like a good one to check on our calculator, get a little calculator experience. Okay? So we're taking the derivative of 3 cosine of 2x, oops, at pi over 12. I'm hoping we get -3. And we did. We got that numeric approximation of -3. Correct to 3 decimal places. Okay, number 6. Now we have f of x's cosine to the 6th of x. I see a power. I am going to immediately write this as cosine of x all to the 6th power. Immediately. You will make fewer mistakes if you take the time to do this. Okay? So for the derivative, I'm using the power rule. So 6 comes down, I leave the cosine x, I reduce the power by 1, and now I multiply by the derivative of the cosine x, negative sine x. Multiple choice answer, they would write this as that. But this would be a safe stop spot right here. Yes, you can leave this 5 outside of that cosine because it's exactly what it means. Cosine to the 5th of x is the same as cosine of x all to the 5th. Okay, number 7. Y is 8 tangent x. We're going to find the second derivative. So first we're going to find the first derivative, and the first derivative, the derivative of tangent is secant squared, so this will be 8 secant squared of x. Now I need to take the derivative again, so immediately I write this as 8 times secant x all to the 2nd power. Now for the second derivative. 2 times the 8. Keep your secant x, decrease your power by 1, and then multiply by the derivative of the inside. The derivative of secant is secant x tangent x. So as a multiple choice answer, they would write this as 16 secant squared x tangent x. All right, find the slope of the tangent line to this curve in terms of x. I see a power, so immediately I rewrite that function using a big power on the outside. Big power on the outside. Okay. Slope of the tangent line, that's the derivative. 4, there's a power. So 4 times the front. Keep exactly what is inside. Decrease your power by 1. Now we need to multiply by the derivative of the inside. So I go to the inside and I need the derivative of this thing now. Well, the derivative of this thing is another chain rule. It's another chain rule. The derivative of sine is cosine. Keep your 3x squared the same, and now multiply by the derivative of the 3x squared, 6x. So this derivative cleaned up would be 24x sine cubed of 3x squared cosine of 3x squared. I need you to notice something about this. We started out with a trig function whose argument was 3x squared. Every argument in our answer must be that then. If you have an argument that is not what you started with as an argument, you've done it wrong. A common mistake I see kids make is that they want to take the derivative of that and put it inside. They want these arguments to be 6x instead of 3x squared. It's just not right. Okay, let's do another one like that. I see a power. As soon as I see a power, I rewrite the original function. No derivative yet. Just rewrite it. big power outside. Now P prime. Power rule, so 7 secant 9x squared plus 2. Reduce your power. Okay? What's inside the parentheses stays inside the parentheses. Now I'm multiplying by the derivative of what's inside of the parentheses. And what's inside of the parentheses is the secant. So secant of 9x squared plus 2 tangent of 9x squared plus 2. That's the derivative of secant of 9x squared plus 2 if we go ahead and multiply by, at the very end, the derivative of 9x squared plus 2, 18x. Okay, let's clean that up for a multiple choice answer. This would be a safe stop spot. Okay, 7 times 18 is, 7 times 8 is 56 plus 5, so 126, 126x, and then we have 6 secants here and another secant here, so secant to the 7th, 9x squared plus 2, times tangent 9x squared plus 2. And that's it. All right, number 10. Find the instantaneous rate of change, IROC, derivative, of this with respect to x in terms of x. Okay, well, I see a power. What is the power? The power is 1/2. I'm going to rewrite this so that it is very obvious to you guys that this is a power of 1/2. So this is a power rule one. So 1/2 times the front. Keep your inside. Decrease your power by 1, and then multiply by the derivative of the inside. 8x plus 3. Okay, as a multiple choice answer, this would be a safe stop spot. As a multiple choice answer, the 8x plus 3 is up on top. On the bottom I have this 2 and this square root. That would be the multiple choice answer. Okay, number 11. Find h prime of 3 if this is h. Okay. Well, I can see doing this a couple of different ways, but I think the way I'm going to do it is using the quotient rule because it looks like a quotient to me. Okay. So I will say this. When we're taking the derivative of the bottom, which we will be doing using the quotient rule, I will be thinking of that as 2x minus 2 to the 1/2, right? But when I start the quotient rule, I'm just going to keep thinking of it as a square root. All right, first h prime of x, and then we'll plug in 3 for x. I start at the top, quotient rule, start at the top, take its derivative. Multiply by the bottom left alone. Minus the derivative of the bottom. Now that I'm taking the derivative of the bottom, I'm coming over here. And I'm doing the chain rule. So 1/2 2x minus 2 to the negative 1/2 times the derivative of the inside, which is a 2. That's the derivative of this denominator. Now I multiply that by the x left alone. All divided by the denominator left alone but squared. And when we square the square root, we just get 2x minus 2. Okay, I'm going to clean this up slightly before I plug in my 3. So I'm going to clean this up. I have the square root of 2x minus 2 minus this 2 cancels with this 2. and I have an x over the square root of 2x minus 2, all divided by 2x minus 2. Okay, I think that's a good place to go and plug in this 3. So now I'm going to plug in 3 for x. Okay, plugging in 3 for x. 6 minus 2 is 4, and the square root of 4 is 2. Plugging in 3 for that x, divided by, we just saw that that was 2, right? Divided by 6 minus 2 is 4. I'm going to multiply top and bottom by 2 to get rid of that little denominator, and I have 4 minus 3 over 8, which is 1/8. How about if we check that one on our calculator, since we're plugging in that nice number 3 and we got a nice answer here. Okay, math 8 of x divided by the square root of 2x minus 2, evaluated at 3. Is that 1/8? Yes, it is. Okay, that is the chain rule.